Today's transformation we are looking at are called reflections. Your essential question is, how do I reflect a figure? Your learning intention, I'm learning to draw and identify reflections and find the line of reflection. So, your warm-up question has you applying the translation vector to the triangle. Your translation vector is 7, -4. Pause the video and see if you can do that on your own. Well, I hope you tried. If we're looking at A, point A is -6, 2. To find A prime, it's -6 plus 7, and then 2 plus -4. -6 plus 7 is 1. 2 plus -4 is -2. So A prime is 1, -2. For B prime, B is the point -4, 6. B prime is -4 plus 7, 6 plus -4. -4 plus 7 is 3. 6 plus -4 is 2. B prime is the point 3, 2. And finally, for C prime, C is the point -2, 4. C prime is -2 plus 7 and 4 plus -4. -2 plus 7 is 5. 4 plus -4 is 0. That's a point 50. Last thing you have to do is to connect the dots. You're going to form your translated triangle by connecting the dots. If you notice, the triangle looks exactly the same as the original. You've just picked it up from here, slid it 7 units to the right and 4 units down. So if you think about a reflection, think about when you look at yourself in a mirror. What happens when you're looking at yourself? Think about the process and how it differs from your original self. So a reflection is a transformation across a line of reflection, and the line of the reflection is a line such that it is a perpendicular bisector of each segment connecting each point with its image. So remember, the line it's reflected over is simply called the line of reflection. That's nothing extremely hard to remember. But the important thing to remember is, if you connect a point with its image, a pre-image point with its image, that segment is a perpendicular, the line of reflection is a perpendicular bisector to that segment. Okay, so it's a transformation across a line of reflection such that the line is a perpendicular bisector of each segment connecting a point with its image. Okay, so now let's start reflecting this triangle. We're going to reflect over the y-axis by simply counting the distance. Because we're reflecting over the y-axis, it will not go up or down. It simply goes right and left. So if I'm looking at n is a 0.34. I'm 4 units away from the y-axis. I need to go 4 units to the other side of the y-axis, and this becomes my n prime. N is 3, 4. N prime is -4, or actually I've only gone 3 there. I counted wrong. This is 1, 2, 3. I've got to go 1, 2, 3. And this is n prime. And this is -3, 4. What about K? K is the point 4, -2. K prime. I've gone 1, 2, 3, 4. I need to go 4 units to the left now. 1, 2, 3, 4. And this is K prime. K prime is -4, -2. Do you see a pattern developing? And finally, for M. M is a point -2, 2. M prime. Okay, I'm 1, 2 units, so I go 1, 2 units here. M prime is 2, -2. Last thing we do is to connect the dots. So if you notice, it looks exactly the same. It just looks like it's flipped over. Look at the point. 3, 4, -3, 4. 4, -2, -4, -2. -2, -2, +2, -2. Do you see a pattern? When you reflect over the y-axis, your x value changes to its opposite. Make an informed guess. make a conjecture, that informed guess. If we reflect over the x-axis, what do you think is going to happen? If you said that the y value would change to its opposite, you would have been correct. Okay, so for the next one, we're going to reflect over the line. Y is equal to the opposite of x. So we know that this line will go through the origin, even though 0 doesn't have an opposite. So let's look at if it's out 1, 2, 3, 4. If it's 4, then I go down 1, 2, 3, 4. 4, negative 4 would be, y would be the opposite of x. If I go clear to the end, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I want to go out to the end and go up, so I have the other end of the good estimation on my line. So I'm going out 1, 2, 3, 5, 6, 7, 8, 9, 10. I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. That one will not work, so I'm going to go negative 9, positive 9. Now that's going to give me a good way to draw this line of reflection. This one should actually be down one more because I went to 5. That looks better. Okay, remember it's going to be the perpendicular bisector of the segment connecting the original point with its image point. So if I'm going to go perpendicularly, I go 1, and I'll go 1 again. This original point is negative 1, 2, 3, 4, 5, 6, 7, 8. And then I go up 1, 2, 3, 4, 5, 6. So, to be able to do it correctly, I am going to look at my rules for reflection. If I reflect over y is equal to the opposite of x, then both of my x and my y coordinates become their opposite, and they switch places. So the first thing I'm going to do for e prime, I'm going to switch their place. I've got 6 and I've got 8. Now I'm going to change both of them to the opposite signs. This is a positive 6, this becomes negative 6. This is a negative 8, this becomes a positive 8. So the new point is negative 6, positive 8. Okay, for f prime, or for f is 0, negative 7. Okay, for f prime, the first thing we do is switch them around. 7, 0. The second thing we do is to change them to their opposite. According to our rule, we change it to the opposite. So negative 7 becomes positive 7. 0 doesn't have an opposite, so it stays as 0. So this is 7, 0. And this will be my f prime. What about for G? The point G is negative. Negative 8. Negative 7. So G prime, I change them around, it becomes 7, 8. These are both negatives, their opposite are positive. So this is 7, and then I go up 8. And this will be G prime. If you notice, I didn't have to count because I knew if this is a straight here, this has to be, if this is perfectly vertical, this one has to be perfectly horizontal. And this gives me my new translated triangle. I forgot to identify E prime. Okay, so if you're looking, it flips it over, and you can see how it also turns it around to where it looks like it's backwards. So you've got these rules for reflections across a coordinate plane. Reflecting over the x and y axis are very easy. You keep the same coordinates, except if you're going over the x-axis, y becomes its opposite. Across the y-axis, x becomes its opposite. If we have a reflection over the line y equals x, then all you do is to flip the x and y coordinates around. We just did the line y equals the opposite of x, and you can see how both of them switch. The x becomes the y and the y becomes the x, and then they both become the opposite of what you originally had. So using this table, we're going to reflect according to the rules. Okay, this is my image. The triangle has vertices of negative 4, 8, negative 10, negative 4, and 6, negative 3. We're going to reflect it over the x-axis. I look up here. It tells me what I need to do is change my y value to its opposite. So if I'm looking at D prime, the negative 4 does not change. The 8 becomes its opposite. Negative 8. Okay, what about E? The x does not change. Negative 10 is still there. But now the y becomes its opposite. Negative 4 becomes positive 4. 6, 3. For F prime, the 6 doesn't change, but the 3 becomes its opposite. Okay, now what happens over the y-axis? If I look up here, across the y-axis, now our x becomes its opposite. So if I'm looking at -4, the opposite of -4 is +4. The y value stays the same. For E, the opposite of -10 is +10. The -4 stays the same. And for F, the opposite of +6 is -6, and the y stays the same, -3. Okay, now for the more challenging, we're going across y equals x. When we reflect it, we just change the x and y values around. So, instead of -4, 8, it becomes 8, -4. Instead of -10, -4, it becomes -4, -10. Instead of 6, -3, it becomes -3, 6. So if you use the rules, you can find the points without ever having to graph them. So how do you know you're successful? When you can draw and identify reflections and find the line of reflection. We didn't find the line of reflection today, but we will be doing that tomorrow. Our next class period, actually. So this is reflections. And there's a table of rules. Are these all the rules? No. If you have a vertical or horizontal line, like we did in the first example, all you do is count. You count from that line, and then you count to the other side of the line.